In this lesson series, we will introduce some concepts from psychology and take a look at how psychologists understand learning, remembering, and forgetting, and then connect it up with what we've learned about the brain. First, we'll encounter a couple of terms, storage strength and retrieval strength, and then we'll tackle a couple of questions. What happens when we study, and why can we remember? In future lessons, we'll deal with the bottom two questions. Now, storage strength, then, is related to the strength of the memory trace in the cortical memory systems as a consequence of consolidation. You'll recall that what's in working memory has the potential to be written into the long-term memory system by way of the hippocampus and system consolidation. So storage strength is related to the quality of consolidation. When we consolidate multiple times, we are strengthening synapses. This was synaptic plasticity, strengthening the connections between those allocated neurons that make the memory traces in the cortex. So before consolidation, we would say the storage strength is low because the synapses are weak between the allocated neurons. But after consolidation, due to synaptic plasticity, we increase the synaptic strength between allocated neurons, and we increase the storage strength of the memory trace. In addition, we learned that events that occur recently in time generate memory traces that show significant overlap in the hippocampus, and the effect of this is to link the cortical memory traces. So event 1 and 2, if they happen close in time, those events can be linked in the cortex. And this is how we can build our semantic memory system. In a brain like this, we see the individual has learned about photosynthesis and relevant concepts that are related to photosynthesis. And the solid lines indicate strong connections between these concepts. So this individual understands photosynthesis, and that concept is well integrated into their semantic memory, as opposed to this individual up here with dashed lines indicating weak connections. Well, storage strength is also related then to how interconnected the information is with already stored knowledge. With greater integration, storage strength increases. So storage strength then is sort of how well is the information physically stored in the long-term memory system and interconnected with other relevant related knowledge. The second term is retrieval strength, and this is a measure of the ease or speed with which information can be retrieved. It is associated with how efficiently the working memory system can access information. So while storage strength is related to the long-term cortical memory system, we're going to associate retrieval strength with the working memory system, the short-term, fast access, limited capacity working memory system. Now, we used a computer analogy in past lessons. The working memory system is like the RAM in the computer. Limited capacity, but fast access. Recently processed information can be temporarily stored in the short-term memory system for fast access during ongoing processing. So high retrieval strength for a bit of information occurs when the information is currently in working memory, or the information was recently in working memory and synapses in those neural circuits were temporarily strengthened so they can be quickly reactivated. And we're going to call this the working memory boost. So if information was recently in the working memory system, we're going to say that there is very quick access to that information, and we're going to call that the working memory boost. It's a condition of high retrieval strength because we still have the information stored in the short-term memory system. So retrieval strength is high when information was recently in working memory. We'll call that the working memory boost. Another way to have high retrieval strength is to have strongly stored memory for the information. This ensures relatively quick and reliable retrieval. Now, we said that the long-term memory system, the hard drive, is a bit slower in the access of information than the fast access short-term memory system, the working memory system. But nevertheless, if we strongly store the information, we have relatively quick and easy retrieval of information. So retrieval strength is high when information is strongly stored in the semantic memory, and so we would say then that's a condition of high storage strength. So when we have high storage strength, we will tend to have higher retrieval strength. We can access that information because it's well stored in the cortical long-term memory system. So again, to review, there are two ways to have high retrieval strength. We have the working memory boost, information that was recently in the short-term memory system, And we have high storage strength of the information. The memory is well stored in long-term memory, so quickly and reliably accessed. So let's apply these concepts of retrieval strength and storage strength to the condition of studying. Well, what does studying do? Well, studying makes retrieval strength high. Information is easier to retrieve after we have just reread a passage or restudied our notes, or perhaps we've been using flashcards or watching a lesson. And we said the high retrieval strength during an initial study session is the working memory boost, because we've loaded up that information into the short-term memory system. But now we must be careful. When studying, we must not mistake our immediate access to information for our ability to access the information at a later time. Another way to think about this caution, slightly differently put, is to think about the distinction between understanding and remembering. When studying, we might think we understand the information, but understanding is not the same as remembering. The only way to find out if you will remember what you understand is to test yourself later on. So, to the question, what happens when we study? We increase retrieval strength, and this is the working memory boost. Now, if consolidation is successful later on, for example, sleep is involved in that process, then we increase storage strength, and that will then also cause an increase in retrieval strength down the road. So why can we remember? We currently have high retrieval strength due to recent study, or we have successfully increased storage strength so we can retrieve later. And that's the process of system consolidation, where we're strengthening those cortical memory traces. So again, remembering might be due to the working memory boost, or remembering might be due to high storage strength, successful consolidation. Remember, system consolidation is this communication between the hippocampus and the cortical memory traces, where synaptic plasticity is taking place in the cortex, and a lot of that is happening during sleep. The result is we have a strongly stored set of memory traces that are well integrated into our semantic memory, and we have relatively then good retrieval of that information later on.